Give me 1 minute. Okay. Why my camera is not working? Right. Give me 1 minute. I double check with my camera what happened to my camera. Is it working? My camera? My camera is not working. Alamak, how Ayah. One minute. Anyhow, my camera is not working. I cannot show you my face already today. Right, anyhow, today got a lot of things that I need camera. Because got framing, I need to show you my direction of that one. Wait. Oh. Okay. In case cannot, then I gotta use Zoom. In case cannot. Okay. This one okay. Anyhow, I don't want to use Zoom right now. Okay. Alright. Let's start our revision today. Before we start, please help me to click that link that I sent there. Help me to leave a comment there. Alright. I really wish you can help me lah, right? Because your comment, why you need to comment? If you comment there, the more that you comment, the more that the YouTube will use their AI to calculate and then to promote my video, so more people will see my video. Okay, that's all. Right? Comment, you don't need to spend money, right? Right? It is free, right? I don't ask you to donate. No, right? Okay, you help me to comment. Thank you. All right, so we start from here, right? First of all, when we do this one, right? So what we need to do is electromagnetism. It comes from the word of temporary magnet. All right, because of electro and magnet. So electro and magnet. Right. Wait. Electro and magnet. So it comes from the word of electro. Where am I? Temporary magnet, right? Produced when the current flow through a conductor. Temporary magnet. So it comes from the electro is current, right? Electron flow, then you got current, right? Current flow, then got magnet. Temporary magnet, right? So it will not last long, right? When no current means no magnet. So if we try to use solid, right? So any solid, any bar or not solid also can, alright? So you turn wire with it, we call it solenoid, alright? So if we use hard iron, so you find it 1, 2, 3 pin is attracted, right? When you turn on the switch, 3 pin is attracted. Copper, same. 3 pin is attracted. If I use wood, got pin or not attracted? Most of you will answer no. Answer is yes, still 1 pin is attracted. Right? Mean it is weak. But if I use soft iron, right? If I use soft iron, so the pin attracted will be more. Right? So we know that no matter what, you are having magnet. Right? Now, if I turn off the switch, right? This one all will drop. Right? Mean it can magnetize and demagnetize. Right? Iron can be magnetized and demagnetized. But if I use copper, if I turn off the switch, then 1 pin still attracted. Right? Mean this one copper or steel also can. Copper will become a permanent magnet. It becomes a permanent magnet. Right? You need to know. So when I turn off the switch, right, for wood, right here, 1 pin is dropped. Soft iron, when I turn off the switch, then all of it will be dropped. So the main thing is, if I use iron, it is the best one, alright? Because it can magnetize and demagnetize. If I use hard iron, yeah, can magnetize and demagnetize, yes, but not strong enough. So I don't want to use this. Alright. Copper, it can magnetize, yes. Can demagnetize? No. It will become permanent magnet. So it cannot be demagnetized. Right? Wood, the problem is it is not strong enough. Right? So what is the conclusion that we can get from this experiment? So we can say the type of the material used for the core, right? It will affect our electromagnetism. Right? So iron can magnetize and demagnetize. Alright. Copper or steel can magnetize but cannot demagnetize. Alright. And then soft iron is very, very strong. Alright. If you use soft iron. Alright. This is the conclusion. Alright. And number of the coil, if the more the turn, alright, we try to do more experiment here. Alright. So here, if I do less turn, alright, I know soft iron is the best already. So I do less turn. Right, and then I do more turn, alright, and then I turn on the switch. I see the more the turn, alright, the more the pin attracted, mean the stronger the electromagnetic field, right? So I guess this one you know, right? So the number of the solenoid in the coil, the more the turn, the more stronger the electromagnetic ism produced, alright? And then lastly, it is the size of the current, right? So if I use 2 batteries and then I use 4 batteries here, so I find it the more the pin will be attracted also, right? So the size of the current also affect the electromagnetism produced, right? So this one is the basic thing that you need to know, alright? We quickly go for some question here, alright? Now, be careful. Hey, teacher, you said copper will be become permanent magnet. Yes, I do say so. Right? But this one is copper wire. Right? You have to be careful. Not copper core. This is soft iron core. Right? So now the number of the pin attracted, right, can be increased by first one. Right? We look at this. Increase the thickness of wire. Increase the thickness of wire mean resistance is smaller. Resistance smaller mean current is more. When current more, right? So more current, more electromagnet, right? So yes, this one correct, right? Increase Now the number of the turn in the solenoid. We see the number of the turn in the solenoid. Yes, the one that I just told you just now, right? Now the third one, alright, decrease the resistance. Alright, decrease the resistance mean more current, right? Resistance decrease mean more current, right? So D is the answer, right? 1, 2, 3, all correct. All are correct, alright? So first part already, so we look at the second part, alright? So first thing that we need to see is right hand grip rule, alright? right hand grip rule. So we see the right hand grip rule by using this way. This is the direction of the current. Alright, the thumb represent the direction of the current. Right. This one is the direction of the current. Right. The thumb show you the direction of current, and then this one. Alright, this one is the direction of the magnet. Alright, magnetic field produced when current flow through. Alright, so there must be a magnetic field surrounding there. So the direction, okay. If I put one at the back there, you see it show in this direction, right? At the back there. So this is the current. Let's say this is the current. So this is at the back there, right? The compass. I put one compass at here, so you point to left hand side. So I put it at here, then you point to me. Alright. So if I put it to here, you point to here, and then here, same thing. Alright, you turn in anti-clockwise direction. Alright. Now if you go down, you gotta do it in this way. Alright. So first example, we are gonna see first example. So alright. So when I turn on the switch, right, the current turn on the switch, the current start to flow. You need to see where is the direction flow, current flow up. The current flow up. If I put it to here, alright. So now where will it point? Here. Where will it point? The current flow up. Right hand grip rule. Alright. This one is going to point. This one is going to point this way, right? This one at the back there, point here. This one, point here. This one, point to the right. Alright, Z to the right. We see Z to the right. Z to the right is here. Alright, Z to the right, no others. So I double check Y. So how about Y? Y is flowing upward. Alright, yes, correct. And then here, X is going to the left, and then W it is going downward. Alright, correct. Alright, so answer will be A. So apart from here, alright. Alright, apart from here, any question you can stop me and ask me in the YouTube. Alright. To be honest, I don't look at my WhatsApp handphone. And I don't look at the what's that called, Telegram group right now. But later after 9, then you can ask question there. If you got any, you ask there, then I will answer your question also. Right? Okay. Now if the current go in and go out, how? Right? We are gonna see. Right? If the current go in, right, it turn in this way. So this dot mean the current go in. This is the dot that showing you the current is going in. So this one show you the current is going. Sorry, this one is going out. I'm sorry. What am I saying? Right. This one is going out. Right. Out. This one X it is going in. X is going in. This is out. This is in. Right. How to differentiate it? Alright. You see here. If I throw an arrow to you, alright, you see a dot here. Right. You see the dot is going out from the screen, from me to you. Alright, you see do you see a dot there? You see a dot there. Mean the pencil, the arrow, the pencil is going outward. Right? The pencil, right, is going out from the screen out to you. Right? So out, then I'm going to do it this way. So this is the direction of the field. Right? This is the direction of the field. Of course you can draw it into this way. I don't mind. Alright, you can draw. Alright, but normally we will just draw 2. You don't need to draw so many. Alright, so many it becomes so annoying. Alright, so now if the current go in, alright, in. So in it is in. This is the direction of the current go in. Alright, this way. Alright, it turns into this way. You need to know how to draw. Alright. So you need to know how to draw. Now, how to memorize it? Very easy. Alright, you see the error. Right? If you see the error, so when I throw the error, your eye is here. Right? You see a dot here. Dot is going out. Right? X. You see the tail of the arrow. Right? Right? The arrow I shoot it for you. Alright? The one that I see here, it is X at the back there. So you see from this side. Right? You see X means the current go in. That's how you memorize. If you got other way, better way to memorize, just go ahead. Don't follow mine, right? So now in a diagram, right? Use a diagram, state observation when the current flow into the same direction and opposite direction A. So if A is flow into the same direction, so I don't care. So either 2 dot, right, or 2x. I will do both for you, right? I'll do both for you. The current both going outward and the current both going inward. I want to see what's gonna happen. Alright. So first of all, I want to draw the field. Alright, this is the field produced. This is the field. Right. So I use other color. Right now, I use other color. Right, I use other color. I want to see what's gonna happen. Alright. So first of all, now this one go up, go up. Go out, the current go out, so the field going this way. Right? So now the other one for this one, the current go out also. So going this way. Alright? This way. So what happened? You see these two, they eliminate each other. So mean the first going up and go down, gone. Gone, no more. So there is a force pushing this way, right? And then this is another force that pushing this way, right? So you got a force pushing here, you got a force pushing here. So these two wires will stick together. When it flow into the same direction, the two wires will stick together. All right. But teacher, you said flow into the same direction. All right. This one go out only. How about go in? All right. We double check. All right. Go out. Go out. So the one that you see is the tail, so the current go in, go out, right? Go in, go out. This one go in, go in, it is turning into this way, the ballet. So the ballet, this way. And then the black one, alright? So black one also go in, alright? The current, alright? So meaning that the black one going downward this way and then going up this way. So what happened is you see these two down, two up, alright? They are cancelling each other. So what happened is I got an extra force. It is pushing here, right? Turning this way, and then this one is turning this way. So this one you got a force, and you got a force. These two wires will stick together. So no matter what, the current flow into the same direction, they will attract together. Right? So what is the observation? Observation is it will attracted together. Right? Two wires attracted together. When it flow into the same direction, right? But how about it flow into the opposite direction? Right? So we need to draw. So got one dot, right? One going out. The other one that going in, alright? So I don't want to draw another one, right? So I just draw one enough, right? So this one, the black one, right? This one is the field produced by the red one, right? I want to see what happened. So for the black one, alright? So the current go out, go out, go out. So it's going down this way. This one going up. Alright, you see it's going out, up, sorry, not out, up. Alright, so here, so this one, the red one, the current go in, alright, go in. So this one is going downward, right? This way it is going downward. This one is going upward. The direction same, you see the direction same. Just now these two directions, opposite, this one. So here you got one force pushing this way, the red one, right? The black one, you got one force, it is pushing this way. So you got force pushing this way and pushing this way. So these two wires, it is going to repel. When they flow into the opposite direction, it will repel. Alright? So now you of course you ask me, Jaegu, this one is going pushing in, or yes, this one is pushing in, yes. But the middle here, it repel first. It is stronger. The nearer the field, the stronger it is. So repel, it is far away from there. So this force, it is too small, right, compared to the middle force here, right? So this one, they still repel. Sorry, I'm not attract, repel. So the two wires will repel from each other. Two wires that flow into the opposite direction repel from each other. Alright, so I hope this one you are okay with it. Any question from here? Right, I hope it is okay for you. Right, so we try to see. Right, we see some question from here. Alright, so the diagram shows the electric current flow through the X and Y. So now tell me the direction of the compass, right? So right hand grip rule, come on, right? So that right hand grip rule. So this one free mark for you. So you point into this direction, right? You point into this direction, which is going upward. Answer is B, right? Answer is B. Is that okay? I guess you're okay with it, right? Should be no big deal. Alright. Now, we come to the next part, which is direction of the solenoid, right? So, which part will give you a positive? Which one will give you a north pole? Which one will give you a south pole, right? Okay, now, here, this is the thumbs, alright. The thumb shows you the direction of the north, right? This is the balik, not the right hand grip rule, the current flow. This one just now it is current, so this one it is for solenoid only, So when the solenoid, alright, you see this is my solenoid, so the current flow, right? So if the current here I see flow up, current flow up, right? This is north. This side is the north, right? So you tell me, Jaegu, flow down here at the back, there, flow down, at the back, flow down. And we don't see the one that you see right now. It is at the front. You always see at the front. Of course, at the back there it is going down, but still, where is the north? Still that side. This side it is not. Alright. So if turning this way, you see. This one go up, right? So this one will be north, right? So if going down this way, the one that I see it is down, you see from here. So it is down, right? Down. Then it is this side. It is a north. Down. This side it is north, right? So down, right? I hope you are okay with it, right? So always look at this direction. This is the north, right? The direction of the thumb, the thumb show you the direction of the north. Alright. So now first of all, we see one example from here. The current flowing here, it is up. Right. Tell me the polarity of M and N. Right. Tell me the polarity of M and N. So M will be north. M will be north. And then N will be south. I guess you are okay. Not too hard for you. Alright. Now, tell me the polarity of P and Q. Alright, P and Q when the current flow. Alright. The current flow to here, and then go to the back, and then going downward. This one is going downward. Right. P it is north or south. P it is north or south. Current go down. P it is going, current go down. Right. Current go down. This is the current, right? For solenoid only, not for the wire that flow in one direction. Right? Don't take that one. That one will be, this one will be current. Right? So for solenoid, come on. So P will be, help me. P will be north or south? For those that you are behind, you please forward, right? Forward. If not, you are always behind. You're always behind. You forward, you pull the video forward so that you will like. If not, you always behind. Then I have to wait. To be honest, the YouTube live it is like 10-second delay. 10-second delay. Not like Zoom. Right? Zoom that I use, right? It is instantaneous. Right? Instant. Right? Few milliseconds only. Right? Maybe lah. Not few milliseconds. It is like less than 1 second. Right? But this on YouTube, it is delay. Delay for like 10 seconds. I tried before. P it is not for sound. I mean P it is. Q it is. Answer me. Answer me. Come on, answer me. P it is. South, right? Q it is. North pole. Is that okay? Right, I hope you are okay. Now, if they ask you, draw the direction of the compass here. Alright. The compasses here, you need to draw the direction. So we know it, right? From you are in from 3, right? You know this one it is a north pole, right? Q it is a north pole. We know that Q it is a north pole, and then this one it is a south pole, right? This is the south pole, right? So you need to draw from north to south, right? Your field need to draw from north to south, right? You need to draw from north to south. North it is going out, right? South it is going in, right? In. From north to south, right? This one it is going out, right? This one is here. So if you put the compass at here, then you will see, oh, the compass will point to here, right? If you put a compass at here, it is going to go to the right hand side. You see it go to the right, right? See, this one salah lah. Yeah, what am I doing? Yeah, this one from north to south lah. Yeah. North to south, I'm sorry, north to south, So this one will point to the left, not to the right, to the left. This one point to the left, right? How about this one, right? You see from here, this one will point to the left, right? So this one is point in, right? You see it point in, right? That's all that we have, right? I hope you are okay with it. Okay. Any question from here? I hope you are okay, Alright. So if you are okay, then we move on. Okay. Now here, when I got this one, alright, I switch on the switch. So the current flow to here, alright, flow down, right, down to here, down to here. This one is up, right? You have to see it, right? So tell me, what is this pole, right? Down. What is this pole? What is this polarity? This pole will be, answer? This pole will be a down. Help me. This one will be a north pole, right? So when this side is north pole, so the other side will be a south pole, right? So how about this solenoid? Right? This solenoid. Right? This one will be a north pole. This one will be a north pole. And then this one will be a south pole, right? So what is the observation when the switch is crossed, right? So it will move away from each other. It will repel from each other, right? Repel. The two solenoid will repel from each other. Right, the two solenoid will go away from each other. Is that okay? Any question from here? Alright. So we do some questions here. Alright. So diagram 17 shows the bar magnet PQ hang freely at the end of the solenoid. Right. So here. Now tell me. This one go up. This part will be north pole or south pole. This part having right hand grip rule. This one will be north. So this one will be a north pole or south pole. This one will be north pole, right? How about here? How about here? This one will be a south pole. So north and south, north and south, north and south. So bar magnet P, right? Yeah, correct. Very good, Fiona. Right. So this one will be a no, right, delay, right? I know it is delay. That's fine. I say the answer already. Alright. So P and Q are P and north and south, right? So bar magnet P, what happened? Bar magnet P, what happened? Right? Move toward or away, right? So away, out, away, out, toward betul, right? So we see this one south and south, right? South and south, alright. So left these two, alright. So this one move away, right? South and south repel, right? Answer is D. Right? I guess you're okay with it, alright. This is easy question. Let me do first, right? Later give you harder question, right? Number 38, right? I want you to try 38. Question 38. What's the answer? Read properly and give me an answer. 38 here. Right. Question 38. Answer? Number 38. Number 38. Only one board. How about others? You drag forward, right? For those who are behind, you are at the back, you drag forward. You drag the video forward so that you see the latest thing, right? You can join the pool, right? You get wrong, then I need to explain to you in more detail. I don't purposely lah. Every question easy one also. You waste your time, you waste my time, you waste everybody's time, right? I cannot see who are you, right? I don't know, right? If you are doing the chat there, I also don't know who are you, right? But I know Fiona, she's my student, I know, right? Right, answer. 2 word only. I wait for 5 words. If not, you wait me, I wait you. You wait for me, I wait for you. Okay? Everybody is waiting, right? While I'm waiting, then I can play some that one. Right? I will play something. Right? This is the game that I'm playing. Eh? Alright. Huh? 4 watts. One more watts. This one also don't know how to sit for SPA. Hello, I'm waiting for you. One more watts. 12th person is viewing right now, but you don't know how to do this question. You are kidding me. You are killing me. To be honest, that you are killing me. Alright, 5 watts. All answer correct. Right? So, very good. Right? 100% B. Yes, correct. Increasing the number of turn. Right? So, we talk about this, right? Electric bell application, right? The use of the electromagnetism can be electric bell, and then it can be circuit breaker, can be electromagnetic relay, and then and many others. Right? If not mistaken, previously I said I still remember when I taught you. I said electric bell I explained, circuit breaker I explained, but I don't explain relay. So now this time I choose one to explain, which is I choose relay to explain. Right? So we see how. Right? So what is relay? Right? The function of relay, you see the relay switch. Do you see in next chapter, chapter 5, electronic, right? You use relay, right? The function first, use little current in primary circuit to switch on the secondary circuit. This is a function. You use little current in the primary circuit to switch on the secondary circuit, right? So what does that mean? I still remember the one that we have learned in this one, right? If I got the circuit here, let me spend some time to do it. This is an automatic. Not. This is the automatic switch. I use freehand faster lah. Alright. So this is the circuit. But sometimes I don't want to put the bulb here, so I need to have another relay at here, right? So this relay, how to draw? Normally they will draw it into this way. You put a diode there, and then this is a secondary circuit, right? So this is another secondary circuit. This circuit will be very big watt, right? Normally 240 watt, right? So this is another circuit, which is you got another switch here. I should draw it this way. For example, acorn, like the one that I showed you in the question before, right? This is 240 watt here, right? Here you put the acorn here. So this is 6 watt. 6 watt is not enough, right? 6 watt, no matter what, if you put your acorn here, it is not functioning. So you need to relay switch. This whole thing, this whole switch is called relay switch. Your aircon need a relay switch. Right? What is relay? Okay, come back to here. Right? I wrote all already lah. Okay. Now, current flow to here. Right? Here it is your current. Current flow to here, magnet. Alright. To here, so you got a current downward. Right? Downward or upward doesn't matter. Not so important here. Right? So what happened when you got current? So this part, this is a pivot, right? So this part is the soft iron. The soft iron will be attracted to here. Attracted to here, then this thing attracted, so this part it is going to push up. So it will come into this way, right? It will come into this way. This one will be, sorry, it will be, look here. And then because of this one is attracted to here, right? Attracted, got magnet. This one soft iron armature here. No need to have north or south. Any magnet north or south will be attracted. Right, so it attract this one. So this part will be, this wire will be pushed upward. So this contact touch. So this is a secondary circuit, which is your ACON. Your ACON turn on. Right, your ACON will turn on. So when you use this one, relay switch, then got magnet, then it will turn on. So it based on the electromagnet. Now, for example, what is the machine that use relay? For example, your car, right? Your car key you put in, and then you boom. This is relay. Your car key there, boom. If you don't want to use car key, boleh. You push your car, you push until half die, then baru can turn on, right? Last time my age, motorbike don't have relay yet. Now boom, your motorbike can turn on relay. No relay, then you need to kick, boom. Hard die, right? Hard die, susah, right? So the machine that don't have relay, for example, the saw, the chainsaw, then you need to pull the engine. That, right? Tada, relay. So if you got relay, senang. So you turn on this switch. Where is the switch, cikgu? Alright, of course it is here. You turn on this switch. Right, you turn on this switch. This one got magnet. This one turn on. Your motor turn on. This motor, secondary circuit. Use little current in the primary circuit to turn on the secondary circuit. Right. Okay. We there? Okay. And then we try to have a look on this. What is catapult field? Alright, catapult field. First of all, 4.1, it is force on the current carrying conductor in the magnetic field. So you must have north pole and south pole. Alright, magnetic field already. So this is a north pole, this is a south pole. Alright. So north pole and this is a south pole, you got a magnetic field. This is a magnetic field, always from north to south, north to south, north to south. And then this one, this is the magnetic field, but produced by the current. When this current go out, right? You see the arrow showing shoot to you. You see the current out to you, right? This dot go out, go out. You see the dot go out. So the current flow this way, right? So when you combine them, combination of this electric field, electric flow punya field, and then permanent magnetic punya field, so we call it as catapult field, right? Resultant of the magnetic field, right? Produced by magnetic field, permanent magnetic field, and current carrying conductor, right? These two field, right? Magnetic field between current and permanent punya magnetic field. Alright, this is called catapult field. So you need to memorize. It will ask you what is catapult field, and you need to write you need to memorize how to write. Okay. Alright, how to draw it. Alright, how to draw it. So now when I bring this whole thing, I bring to the center of here, then I want to see what happened. So you need to know how to draw. This is north pole, this is the south pole, right? So here, this is north to south, north to south, north to south, right? Right, and then the current, right? Current, right? Got two, right? I draw two. I better use other color, alright? So this one, it is out, right? I told you it is out. The current out, So the direction of the field is out, right? You see from here, here, right? This one, this way. So you see this one double up. This one cancel each other. One left, one right. One left, one right. No more. Right? So the force here don't have. The force like from here, keep on pushing. From here, keep on pushing. Keep on pushing. Keep on pushing. So you will get one resultant force that going upward. So you got one force that going upward. So that you got this. So it is actually come from here straight, and then here got magnetic field from the current, and then magnet combine, curve a bit, right, and then go straight. Okay. Go here and then curve a bit and then go straight, right, curve a bit and go straight. This one cancel, this one cancel, that no more, and left little only, right, left little only if you got. So that you got a force that going upward. So this one we can use framing. Framing say, hey, don't so hard lah, make it easy, right? Okay. Framing said, this one actually I do revision, so I will skip this one. If not, I will do one by one with you. So I want to use framing. I haven't go for framing, but I want to use framing. If not, it will take me a lot of time. Right? Probably I do one enough. Right? I do one enough. Draw the catapult field, right? So draw the catapult field. It is actually north to south. This one we have done. Never mind. North to south. North to south. I draw 2. I draw 3. North to south. I draw 1. And then I draw 2. And then I draw 3. Right? And then your catapult field here. Wait, not yet catapult field. So this is the magnetic field produced by the current that flow in this way, clockwise. Okay, clockwise. Yeah, I draw here, no point. If I draw here, then how? How do I know cancel or not? You don't know. So don't want to draw. Don't draw there. Right, draw here. You can see the direction. Oh, this one cancel. This one cancel. This one cancel. This one double up. So double up, so you got one force, right? So the question asked me, draw the catapult field. Yes, I know how to draw. So this is north, this is the south, right? This is north pole, this is south pole. This one goes straight, this one goes straight and then curve a bit and then straight. Oh, this one is current go in, go straight and then curve like that, right? Something like that. Draw 2 or 3 enough, no need to draw so many. Right, these one like cancel each other, no more, left one more, okay. Just left one, right? So the direction of the field, the force, it is going downward. This is the direction of the force. That's what we have, right? Is that okay? You understand, right? Are you okay? If you understand, you put thumbs up for me. If you understand, you put a thumbs up for me. I want to see. I'm looking for the thumbs. Yeah. Or happy face or whatever lah. I cannot find the thumbs. Right. Thumbs up, or you put a happy face for me if you understand. Okay. Right, I will teach you another way, easier way. Right, I will teach you another easier way to do this. Right, you don't need to spend so long time. This one susah. Right. Right. So, okay, good. Right. Only 2 people understand. That's so bad. So what you do is you use framing, right? I guess the who come to here already prepared for your SPM. So you agak-agak know lah, huh? This is north to south. You point north to south, north to south. This is magnet Right, 4 finger it is magnet. The middle finger it is current. This is force, right? The thumbs represent the force, right? You you point north to south, and then current go in, right? Oh, this one the current go in, yeah. This one the current go in, right? North to south, current go in, force go down. So what do you do is, I said just now, I will give you a easier way to do it. The force go down. So once you know the force is going downward already, you know the force is going downward, you use framing first. This one cannot draw, got something blocked, don't draw it. You draw here, agak draw here. North to south, finish, end of the story. You see? Same. Here you want to draw one. Because got something blocked, very hard for you to draw. You draw one. That's all. You know the result, baru you draw. Right? Easier. Right? If you understand, use the way you need to rub here, rub there, and then draw. Right? Now you use framing, then you can get it. Right? So now I want to use framing first. Right? This one, where will it go? The force. Right? I point north to south first. Right? North to south. I point north to south. North to south. North to south. Right? North to south. Okay? Current go in. Force go upward. So I find it, the force is going upward here. So when I know the force is going upward, so the rest is like north, I draw to south, curve a bit. Like that. No need to draw so nice. Like that only. So this is the direction of the force. Is that okay for you? Is that okay for you? Right, okay, right? Right, so the rest, right, I don't want to do all, so I choose some to do, right, this one. Right, this one, how to draw, right? So, this one is, where is the direction of the force? Help me. This one, help me. The direction of the force. Direction of the force. Direction of the force. Where will we go? We point north to south, and then the current in or out. We are doing the revision, right? Of course, we know this is easy. If you was in the group that I discussed one question to the higher level one, I don't think you can do it. This one is very easy, right? The one that 3D model one, right? If you see lah, right? I did get them the question until most of them don't know how to do. Right? That one too complicated lah. So now we all talk easy one. And for 5, kacang lah. Piece of cake. North to south, current out. I see the current out. So you go this side. You go this side, You go this side. Here. Here, north to south. The thing that you need to draw here, right? This one little. This one, you want to draw, you draw more. North to south, finish. End of the story. Are you okay? This is the direction of the force. Meaning that this conductor, this wire, this is a wire. So meaning that here it is a north pole, here it is a north pole, here it is a south pole. So I got one wire throw out. I see it throw out in between north and south pole. Then this wire will pull to this side, right, by a force. That one is kata force. Force. The force produced by kata force. Produced by current punya field, current punya magnetic field, and magnet punya magnetic field. Right? Okay. So we straight away go for some other example. Like here, right? We see. Now tell me, what's the answer? Right? Answer. Question 32. MRSM question 32. Question number 32. You can try to draw it if you like. Two watts right now. I'm waiting for 5 watts at least. I can see here majority of you get wrong, so I need to reteach. Right, 5 watts, right? I'll see majority of you not really sure, right, on how to do it. Right? You see, because of 5 watts, so 3 of you are putting A, and then D is 40%, mean 2 of you bought D, alright, and only A and D, right? So never mind, alright, I know you're not sure, so you're not sure, then I need to reteach. Mean I know you don't know, I know that you don't know, right? So this, I put it to here, I go slower, never mind, I know you don't understand. So this is not Paul, and then here will be a support. Right, so what I do is I draw here. This is the field, this is the field from north to south, right? From north to south, I leave some space for my current. Right, so my current is going in, the current is going in, right? X is going in. You see the tail of the arrow, right? So now I use black color, right? Black color. So now have it go in. You see the direction of the force, it is here. You see it is double up here, and down here, down. Go in, down, go in, down, go in, down, alright. Now it's going to this side. Right. So you see this one cancel, no more. Finish. So here got a lot of line, got a lot of curve. Yeah. See? So where is the force? The force is going downward. Right? Am I right? So answer is D. Right? If I am using framing, right? So north to south, later I'll teach framing in detail. North to south, right? Current go in, force go down. Right. So I already know force going downward. Don't care about this one, don't see this one, so annoying one. Here little, here a lot. Go straight and then curve like that. Normally lah. Right. This one, no. This one north to south already the direction wrong. This one north to south the direction already wrong. This one should be upward though, the force. You see, here got a lot of force pushing. So go upward. Am I right? Alright, so answer is B. Actually haven't framing now baru this one actually haven't. It might not something wrong. Framing here lah. Yeah. So we use framing. Right. I can explain to you what is not, what is this, right? But without using framing. But I try to lah. Better. So now framing left hand rule. So this one is magnet. Right. This one is magnetic field. Right. This one always from here it is north, here it is south. Always point from north to south. Mean this one is north, this one is south. Right. Framing left hand not right hand left hand left hand you know left and right. Some of you don't know left and right. Turn left, GG. Right, turn left. I asked my wife, turn left. She gonna turn right. I have to say, the one that you are carrying the spoon, right? 拿筷子的. Oh, she know. Oh, okay, go to the right. Okay. This one north, this one south, right? So point north for south, north to south. Right? Always point north to south. Always, number one, always do your magnet first. Don't do the current first. You do the current, later very hard for you to do. Right? Second one, go get the current. Lastly, baru go get the magnet. Right? The magnet, not magnet, the force. This one is magnetic force produced. So normally we call force out. You can call it magnetic force because it's magnet punya force lah. Magnet push it, then got one force. Magnetic force nothing wrong. So you could, but normally call it force lah, right? Okay. Come back to here. All right. Come back to here. Now we are going to see some easy example from here, right? Come back to here. So how about this one, right? So now here, point north to south, north to south. This is north, this is south, point upward. I'm taking this example, north to south, go up. Current. Now, after this one, you don't move this one already. This one fixed, alright? Current is here. Second one, they are, first thing, they are always right hand, they are always right angle to each other, 90 degree, right? So, and then second thing is, some of you like to do this, which is I teach so many, I know, like that. You see, if I point like that, you think it is polite. You think Fleming is a very rude person. So no, Fleming never put a middle finger out. No. Fleming's doing this way, never like that. Right? If like that, no lah. Okay, I mean, you know lah, cannot point that one out. Right? This one rude. Right? So, okay, and then first one point up. Right? Polite, point up. Second one, the current. Now this one cannot move already. So the only thing that you can move is your current. Your magnet cannot move. You move your current. This current go up. So current go up. So I know. Oh, the force is going this side. The force is going this side. That's all. Right. Okay. I try to do one example from here. I just simply take one, right? So I do this one first, right? North and south. This one I didn't draw for you. Yeah. I should draw for you. But I see time enough. Later I draw one catapult field. I think you will need it. Right? I draw the catapult field and then I explain the Fleming letter. Now you see I do this one as my example of I use catapult field to do it. Right? From north to south. Right? This one probably I need 2. I need to draw here from left to right. I draw 2 arrows because I need to use it. Right? Here from north to south. You draw one, it is not really enough. Okay, now once I do the black one right now here, this one, Okay, so the black one, so the black one, the current out, right hand, not left hand, right hand, right? So this one is coming into this way. This one opposite direction. You see, this one cancel, this one cancel, right? I use other color again. So how about this one? How about this one? This one the current go in. Right, this way. Cancel. 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 So this side cancel. This side double up. This side cancel. Right? And then this one double up. So what we have is the outcome will be something like this. Right? This is my south. This is my north. This is my X. This is my dot. So the current like at first going straight and then curve. And then here, no more. Right? At first and then come, no more. And then this one, you know the direction is going this way. Right? Going this way. Right? And then come to here and then continue from here. Oh, it come into this way. It come into this way. Right? You see the direction of the force. So let me draw it properly for you. So you see something like that. Am I right? This one left a little bit, come to here. This one left a little bit, come to here. Right? So here, seems like you got a lot of forces pushing this way, but we normally draw one arrow enough. Right? So you got a lot of force that pushing it downward. This side is going downward. This side it is going upward. Because you got a lot of force pushing here. You got a lot of force pushing downward. You got a lot of force pushing it upward. That's what you get. This one is apa ini? Motor. Right? When you got current, then this one turn in anti-clockwise. Okay? But I don't want. Right? This one down, here, down, this one up. Now I use flaming cepat sikit. Alright. Look at this one. Point north to south. Right? Current X. Current is dot. Dot is going up. Here. You don't break your hand. Right? This one. Current north to south. Current turn to you. Alright. So the force go down. I know. You try to break your hand, then you know. Alright. This one is downward. How about this one? Of course upward. But I still need to point. North to south. Okay. North to south. Current in. Current in. X is current in. And force go up. Yes, this one go up. Framing make our life so easy. Right? You don't need catapults. No need catapult field. Right? No need. So you got this one. Oh, I know. Oh, this one is going down. Oh, it turned into this way. Meaning that if my motor, it is something like here. This is my motor. The left hand side of the motor, the current flow in this way. The current flow up. Alright. So this one is down. This one up. It will turn in anti-clockwise. I see. Anti-clockwise. You get what I mean? Okay. As I promised you just now, I said I will explain this one catapult you to you. I dig a hole for myself to jump. And GG, I don't know how to explain. So now you see this one. I don't know how. Too hard, right? To be honest, too hard for me to draw. This one is downward. Downward. 3D. And then you got one field in between, right? Of the current. Right? The current go up, up there. Yeah. The current, you see the current, Alright, you see the current per se. Right, current. Current out, this one, teacher, this one, how, this one down to. Yeah, down, How? Do you know what is this title of this chapter? This subtitle? This subtitle called current carrying in a magnetic field, not outside of magnetic field. Don't talk about outside of magnetic field. Outside is other story. I want in the magnetic field, right? So this one outside what for? I want this one is a magnetic field, right? You see the magnetic field inside the magnetic field, right? Outside I don't care, right? No magnetic field there, only current I don't want, right? So this one, right? So this one is down. I draw 3D. I draw 3D. This one going down, and then the current out. You see, here you got one force. I should use other color. If you cannot see it, then later I use another way to do it. Right. So this one here. This one the field, this one the field. You see the field same. This side it is the same down. The red one is a magnetic field, also down also down. So this one same direction, right? So this side is same direction, so you got one force pushing from here. This one is down, right? The red one, magnetic field one, red one. Now the green one is up. You see, go out, up. You see, upward, right? Upward. So this side cancel, like no force pushing. So it is like got one force keep on pushing here. So this thing it is going to swing upward. So hard, right? Yeah, yellow. I also know it is hard. But make it easy. Make it easy. Do you see a dot that coming out from here, which is current? You put your eye here, you see the current go out. Like that we make our life easier. Same thing. Don't want to use this. Use framing. Okay. Use framing. So this is normal. Because framing simplified it already, you don't need to struggle on it. You don't need to struggle on catapult field, right? You now is not the time. If you really don't understand, leave it. Know how to get the answer is good thing, right? For those who still cannot, right? Don't struggle on how, why, right? I see a lot of students apa itu terus apa itu arus ulang-alik. You're wasting your time. Don't know it already. You focus on how to get the answer right now. But if in my class, then I'll get into detail to you. But now it is too late to know what is arus. You need to know how to answer the question only, right? Arus terus or arus ulang-alik. Okay, right? North to south. Why north to south? Current out. So force go to the right. So you got one force go to the right. That's all. That's all you need to know. All you need to know. Right? If the current more mean this is north, this is south. Current more, right? Okay. Current more. I explain to you. Right? This is north to south. This is north to south. If current more mean this one more. Alright, this one cancel. Right? So the force pushing here it is larger. So of course you swing higher. Right? The more the current, you swing higher. The less the current, you swing lower. Right? From the beginning, no. The more the current, the more the magnetic field. Alright. Is that okay for you? Observation. This one, help me. This observation. Swing left or right, two only. Example A. This one the other. Example A. left or right. It will swing to the left or right. In between the magnetic field. You break your hand right now. Left hand, not right hand. Example number 8, you will swing to the left or swing to the right. Example number 8, you will swing to the left or swing to the right. Three box only. I want to wait for more. Four box. Still got some of you not really sure. Because just now got 50%. Right, 5 watts. Right. I can see most of you get left. I guess which is wrong. Right. So first of all, you see where is the current flow first, right? Where is the current flow? In the magnetic field, right? In the magnetic field. Yeah. In the magnetic field, the current flow. This is the direction of the current, right? Point north to south, always magnetism, current. Current in. You go to the right there. Surprisingly, only one person get correct. Other all GG, tenggelam. You swing to the right. Am I right? You see properly, this is the current flow, this is positive, this is negative. Positive, this one go down. But go down, I told you just now, right? I must see the current flow in the magnet, in between the magnet. So this is north, this is south. Point north to south, magnet, point north to south. Point north to south. Current in. Swing to the right. Huh? Are you sure? You know how to do? Never mind. I give you one more chance, alright? Number 9. Right? You will turn clockwise or anti-clockwise. Right? 9. I don't know who is get correct. You don't need to worry you vote or not vote, right? You learn. This is the process of learning. Right? You will swing clockwise or anti-clockwise. Clock or anti-clock. clockwise or anti-clockwise? Yeah, I spelled my anti wrongly. Whatever lah, you know the second one is anti. This is going to spin in clockwise or in clockwise. Ikut arah jam atau lawan arah jam. Don't know what is arah jam, you go see your clock right now. Go look at your clock right now. Meaning that most of you are GG. I tell you, this chapter is the one that I predict will come out in the AC. So you guys have to, you know, yeah, I should not say. I said more than 20 comments in my that video, then I will tell my prediction. Come with question. But if you join my group, that I did give some question. You do it, then you will get improved. Right, 4 votes only. Other not sure. Tidak tahu. Don't know. You break your hand already? Pusing? Already? Pusing your hand? Right. Okay. This time improve, right? Improve, right? This time got improvement, right? So we see properly in the magnet here. The current, this is positive, current flow to here, A to B, in between the magnet, and then C to D. The current flow from A to B and then C to D. A to B go in. So north to south, point north to south first. North to south. Cannot move already, current in. In. You see in. Force go up. Oh, this one go up. So I got one force that going upward. And then this current is going out. Actually, I don't need to point. That side go up. This side must go down. But anyhow, I want to explain to you. See, right? This current going out. Right? Going out. See the north to south. Current go out. Now current go out. This one cannot move. This one magnet cannot move. Don't teacher like that. You see your magnet become no. This one hold it, don't move. This one hold it, don't move. Turn. Right? North to south, north to south, north to south. Right? And then force go out. Pi to force go out. Current go out. Then force go down. You got one force that pushing it downward. So AB go up, CD go down, which is keep on turning into this way. Clockwise. Right? You see your clock, this is 12, this is 1 o'clock, this is 2 o'clock. It come into, of course, after 12, is go to 1 and go to 2. This is called clockwise. Right? The terbalik of the clockwise is this way. So it go in clockwise. What is the observation? The solenoid, the coil in between the two magnets, turn in clockwise. Okay, last one. Where will this thick copper rod go? Where will this copper rod go? Example 10. Right? Where will it go? Where will it go? If you cannot see, in case you cannot see, I make it bigger. So this one is positive, this one is negative. And if you cannot see, in case this one is positive, this is negative. The current supply. Okay. Probably it is not clear lah. I realized one thing. Clockwise or anti-clockwise, you can do well. Will go left or go right? Maybe the one that you see, the ballet from what I see, is it? Then 我错怪你了。Your left is my right. My right is your left. Oh, you see is laterally inverted. I'm sorry. That's why just now 80% get wrong. I want to ask you you see Fiona, you answer me 你答我Now the one that I draw here, it is left or right? Left or right? I see it's going to the right. When I see it is going to the right. When you see it is go left or go right. Right Correct but nothing wrong Right? Correct Okay. Alright. Done. You say which one you wrong Oh, I say which one you wrong This one question number 8 I talk about question number 8 Question number 8, you see 80% vote to the left Left is this side Left is this side. Left is swing to here. This is left. I see lah, it is left. This one is swing to the right. Then you see question number 8 I see 80% of you get wrong. The current go in. The current north to south. Current go in, swing to the right. Nè. This is north, this is south. Do you see the north and south? Oh, you see both north Oh, you cannot identify which one is north and south. This diagram it is too small. This diagram it is too small. Both end. Both end. This is S leh. You see it as S. You see it as north. Like that. This is bottom blue one is north. cannot see this one 这个没有好讲啦，这个 north and south you cannot see then I got nothing to say. Okay, here. Now the copper rod is in between the magnetic field here. Right, go in, the current go in. Right, the current go in. The current flow to here, and then in. Right, and then the current flow out. And then this one, the what is that called? What is this one, this stick it is, I mean the chocolate color one, right, which is fixed, don't move. The orange color one is copper rod. The copper rod will move to where? Right, this one is fixed. You see, you got something nailed on it. How can it move? Right, still got some of you tell me it move. Killing me. Still got some of you tell me that move down. How to move down? I don't know why you, but how to move down? Not to south. You're killing me. You're killing Fleming Fleming 从土里面钻出来，抓着你的颈。今晚做梦他就进你的梦了。North to south. Why not to south? Current go in from X to Y. The current go in from X to Y. Right? Current go in from X to Y. So, where we go? You go to the right. Logically, you see, you do the experiment. Here got a lot of space, right? If you don't know, here I tell you common sensely, right? Here got a lot of space. You move to here, surely move to here. If the question come to here, then what for I ask you? No place to move, right? Logically lah. This one here got something block. How to go up? Logically lah. Alright. So if most of the time you come to here, I said most of the time. I never said guarantee like that. I never said that. Logically lah. If I said question, of course need to give you some space to move and alright. So where will it move? This stick will move to the right. You move to the right. Is that okay? North to south. North to south. Current in. Move to the right. Okay. Move to the right. Am I right? North to south. See? North to south. Current in. Force go to the right. I'm looking on my other screens whether it is laterally inverted or not. Yeah, go to the right. Okay, correct. Nothing wrong. Okay. Okay. Here, this is North Pole, this is South Pole. Right? This is North Pole, this is South Pole. Now, originally, let's say I got one spring balance. I got spring balance. Now, this one is the one that I discussed before. Later, I got one question I want to discuss with you. Right? But this is north, this is south, right? Here, this is north, this is south. Okay. Now, what happened is when the current flow in, right? So let's say originally you got 5 Newton. Let's say 5 Newton, the reading 5 Newton. Right? I don't turn on, so the weight, the spring balance will give me a reading of 5 Newton. So when I turn on, what happened? The force go up or down? I mean, this force go up or down? Point north to south first. This one I draw on my own one. Don't tell me cannot see where is north and south. The first go up or go down? The force will go up or go down. Example 11. Up or down? Don't want to give you left and right. Impossible to go left and right. Go up or go down? Up or down? Point north to south. Left hand, north to south. North to south. The result is very disappointing. You were wrong, you don't tell me I don't know that you get wrong. Alright? But I know 3 of you vote that one. Alright. So 3 of you, because got 5 vote, right? So 3 of you vote wrongly, which is 60% going upward. So north to south. North to south. North to south, current. This is current, middle finger. Turn in. Force go down. So you got one force pulling downward, alright? Pull it downward. So what happened to this reading? What happened to the reading of the spring balance? Right? Reading. Increase or decrease? Or decrease? Increase or decrease? You got one force pulling downward. Magnetic force. Catapult force. Where we go? You got one force pull. The spring, spring balance, you hang something on it. So you got more force pull down. More force pull down. So increase or decrease? Increase or decrease? Later I'll go get something harder one for you, which is the question that we discussed last week. Number question 38 of MRSM. Oh, increase, right? This one I don't want to spend too long time with you, right? See, now this question is the one that I want to discuss with you, right? So you know increase, right? You understand it's increase, right? So never mind. Here we go. This one I don't want to do first, right? Better. I want to do this question for you. MRSM. So I want to do 26 at 36, not 26. Right? I want you to read properly right here. And the one that okay. Now you see logically so I don't care where is a positive, where is a negative this question not telling me where is positive or where is negative. It is not important also. Which statement is this correct about this one? When the current flow, right? When the current flow, alright. So this is the balance, alright? Electronic balance, electronic balance, right? So you need to press something on it, then you got reading, right? You need to put something on it, baru got reading. Do you agree? Right. You see the thing here, yeah, right? Don't have anything. Then the current flow. So what happened, right? If the current flow is this way, what happened, right? Let's say this is positive, this is negative, like the current flow is this way. What happened? You answer me. What gonna happen? You tell me. If the current flow into this way, this is north, this is south. Why not to south current? Where will it go, the force? It will go up, right? North to south. The magnet here this way, north to south. Then this is the direction of the magnet, right? This is the direction of the current. This is magnet. We use B lah. If you go to from 6, you use the word of B, the symbol of B. But from 5 don't have, right? And then you got the force going up, right? If the current go in, north to south, right? The B is still going north to south, right? North to south, north to south, right? Let's say, don't want. I take this one first, right? If the current go in, right, north to south, right? This is north to south. The current go this way. This B is going this way. I is coming into this way. North to south, current that way. So force go down, right? Right. Okay. Now, but the thing will pull this wire only. Will it compress? Will it compress the balance? No. It will pull the wire. Yeah, the wire will go slightly downward or slightly upward. But you are pressing the A. You're pressing the A. Am I right? You're pressing the A. Now, what, right? When the force acting on the wire downward, the reading of the balance should be increased, correct? Right. But the answer given is when the force is moving upward, the reading increase. No, this one is wrong. The answer given it is wrong. This one is correct. But I tell you, this question is not logic. But the one that I sent to the group, still remember quite long time ago, I did say the thing. I go and find the question. The thing that I screenshot for you when I do the wait. I go to the group. Okay. Never mind. I know. Okay. Okay. This is the one that I mentioned here. Okay. Do you see? Now this one, the one that video that I sent to you, right? So now I don't care where is the north, where is the south, alright? The current is here, this is positive, it come to here, and then it flow to here, right? So it flow to here. You see, you see the white thingy here? Do you see the white thingy here? 有一个白白色的东西 Do you see it? This is the balance, yes. This is the balance, yes. Right. Do you see this one? At the back there, in between the magnet there, 这个透明白色的东西在这里 Do you see? So if you say you got a stick pushing on this one, then this thing will make the whole thing push the balance, then the balance reading will be increased. I agree. This one it is okay. But the one that we are discussing just now, it is mana ada? At the back ada apa? Tak ada. You said the reading will be increased. I don't agree at all. You know what I mean right now? Do you get the idea there? Do you understand what am I saying here? You see, you are compressing the A. So this question is not logic. I told you, unless you draw something. You said at the back there got something. Here. And under here got one thing. You press the thing, then you compress. So the reading will be increased. Okay, I agree. This is the one that I discussed to you before. Do you understand? But anyhow, if at the back there got something, so when the force is pressing downward, right, the reading increase. You understand what I'm saying here? Is that okay? Do you get the idea? Any question that you want to ask me? You can ask me in the group, right? Not in the other physio or therapy. No. You ask me in my PTSC Q&A group. I can answer you. You ask in that group, other people answer you, right? When I free, then I go there to answer your question, right? You personal me, okay. Now you can personal me. I'm okay, but you personal me, other people don't know you're asking. So when I answer to you only. Right? Other people cannot learn. I do this. I tell you I do this is not to charge you money one. I don't have intention to charge you or I want to do seminar and then you guys join buy my notes or all this. No. I just want to promote my PTSC for next year and then all this. So I mean I want to promote only, right? Because if I don't promote, then next year I'm jobless, right? You see, I need to do it from you, right? No, I never, right? So you help me to promote a little bit, right? And then one more thing is do you see the link that I sent here? The link that I sent here, you help me to click this one. Help me to click this and then help me to leave a comment. It will help me a lot already. I thank you very much already. If more than 20, I'll predict some question for you. That's all. If you got question, you can ask me in the group right now. Any question that you want to ask, you can ask me in the group right now. I will answer you. Any question? Any question that you want to ask? Any question that you want to ask me? If not, then I continue to do some question. Okay. Alright, so 32. Come on, 32. You help me to comment. Thank you. Yeah. You can help me to comment. I thank you very much. Comment or like or share will be okay. Alright. Step paper, pahang paper, question. Oh, you see, I got typo 32 or not 31. You see, I got many typo. Right. Example, no, question 32. Right, question 32, pahang 1. Help me. Answer. A, B, C, D. 32. A B C D. Answer. 32. Why not to solve? Karen. Huh? No place to comment? Yeah, ka. But I can see leh. Nah. Nah. Yeah. Nah. Can why cannot? This link I send the link again. Right. I send the link again. Oh, I know now. I sent the wrong link. Maybe. Not to solve. Turn out. If you see, still got 50% do wrong. If you don't know how to answer this question, then you do catapults, no? Catapults cannot get wrong, cannot get wrong, If catapults feel you still get wrong, then I don't know what to say. Right? This is North Pole, this is South Pole. The current go out. Okay. You cannot, then you want to do catapult field, what can I do? Right, current out. Here cancel, here don't have. Then here push. This one you go where? This one you go where? Catapult field. Right. Same right? But framing it is, you need to break your hand. You cannot break your hand, then you use catapult field. What can I do? I cannot do anything also. You have to choose one to do. Right. Answer? I cross that one. Answer is C. Right. Why C? Right. North to south, you see? North to south. Right. Current. This is north to south, North to south, North to south, Current. Out. Now cannot move this one. Turn down. Turn to here. You need to break your hand. Right. 要熬断你的手了。Then force go down. Force going down. Right. The current out. Force go down. Alright. You need to master it. No choice. Cannot then catapult field. Cannot then flaming. Cannot then tembak. What can I do? Right. 39. Answer. 39. Answer. Answer. 39. Answer. Point it. 39. Give me your answer. Hmm? What's the answer? One, two, three. Three votes. All of three of you vote correctly. Four of you vote correctly. You see, practice make perfect. From most of you don't know how to do now. Most of you. One more. Don't break the record. Fifth. I mean one more votes. Then I close. Don't vote it wrongly. Why not to some? Current, I don't know. One more vote. The fifth vote, then I will close the pool. One. Excellence! I'm so happy. Right? Congratulations. Right? Wait, I got a crack, big crack for you. Right? Finally, you got one. Finally, you got one. Oh, correct. I am so happy. I'm so happy. Really so happy. At the end, baru finally got one. Okay. Third, this one question Johor question. Right. Make it double Q, okay? Give me double Q, okay? Johor 32. Okay. Johor 32. Johor 32. Johor 32. This question, I mean this question. Itu macam-macam ada. Got A, got B, got C, got D. Huh? You sure? This one question I thought. Oh my god. I see the board, I will vomit blood. Right, 4 board enough. Right. What are you doing? What are you guys doing? You really understand what is this or not? This is north, this is south, right? This is north. Oh my god. This is north pole. Of course, this one gonna be South Pole, no need to say, right? This one north, this one south, right? North pole into south, right? Current, right? Current is here, current it is here. It flow from here and then go to the copper rod. It is here. In between the magnet, it is here. So all the current is here, right? You point north to south, go up, right? North to south, huh? And then current turn. This one cannot. This one cannot move already, huh? And this one, I mean, north pole cannot move already. Hold it. Don't let it move. You turn here only. So turn out. So where will it go? Where will it go? Where will it go? It go left. Hey. Adma, you guys, are you guys preparing for SPM? You go A, yes. You are the only one get correct. I don't know who is voting, alright? None of you tell me, right? But really disappointing there. Just now I'm very happy because I thought, oh, you really understand, oh. Yeah. Then come to this kind of question, then GG. Suddenly GG. You, huh? Okay. You see, this one's definitely come out one. Objective definitely give you 1 mark. You turn your hand only, then you get mark. You don't want to get mark. Right? Don't say about this one hard lah. Right? Okay. Now I do one more question and last question. One more. And don't forget to help me to comment. Click the link, help me to comment. This link. The link just up there, right? Help me to comment it. Thank you. Right? Which direction it will move? Right? This one is alternating current. Alternating current means the current flow to here, and then flow to here, flow to here, flow to here, here. Right? So north to south, the current flow in, flow out, flow in, flow out. So where will it go? Answer? North to south. The current flow out, then it will go up, right? The wire will go up, right? You got one force go up, right? Push it go up, right? If go in, force will go down, right? So it will go up and down. But to be honest, if you see answer, if you got other answer, not moving, also can. Why? Because it moves up and down too fast. 1 second, but this is alternating current. 1 second it vibrates 50 times. You go left, right, left, right. 1 second go 50 times. You can see it go up and down. Cannot. You can see it vibrate there. It vibrate until very small until you see it is not moving. If you got any answer that is not moving, also acceptable. You understand? Or you use another word. If they ask you in structural question, what should you answer? You should answer physically not moving up and down physically, but actually it do go up and up down. You understand what I'm saying here? It go up and down too fast. 1 second 50 times. So fast, right? You cannot see it is moving. Too fast. It vibrating there. It's like stationary there, but it actually moving. You go and touch it, you see it vibrate. Okay, any question? To be honest, today you guys not doing well. Okay, I will continue to do. I really hope that you put effort on it, and then you really spend some time on it, right? I do revision with you. I really hope you can get a very good result, right? In physics. anyhow, thanks for the lesson today. Right. If last one I want to promote a bit next year if you got brother or sister want to join PTSC, fill in the Google form, ask your brother or sister, fill in the Google form, and February free, right? Next year got promotion, right? Next year February free, fees free, no need to pay tuition, you join only. And then March 49 ringgit 90 cent, less than 50 ringgit, right? We got so cheap tuition fees, you cannot find any other way, right? If you got brother and sister one, ask them to join. If you got friend one, tell them, and then help me to comment. Thank you for everyone, right? Thank you for the lesson. So we are going to continue to do more. Alright, if you got question want to ask me, you ask me in the group. Alright, don't PM me. Alright, don't PM me now. You ask me in the group. Alright, if you are my student, you want to WhatsApp me, okay, you know my handphone, okay. Alright, I'll see you next lesson. See you, bye bye.